So, Willem, thank you so much for taking the time to do this. My understanding is we are going to refactor the counter example into a singleton pattern from what we currently have, which is a contract interface with a collection of methods. We're going to refactor this, and we're going to move through this process, basically starting from a blank folder, npm init, all the way to a basic hello world contract, unit test, get sort of the folder set up. Then we're going to grab the counter contract source code from GitHub, put that in, wrap it with some unit tests to make sure we're good. Then we'll do the refactor, confirm the unit tester, the refactor to confirm the unit tester is still passing, and we should be good to go. That's the plan, right?
Yeah.
Awesome. Okay. Well, I'll interrupt with questions along the way.
No. Well, first I'm going to create the npm init and stick with this counter at this package name. And yeah, sure, 1.0, go for it. Simple example of a singleton counter in AS. Entry point, you can ignore that. Test command, it's test. Git repo, we'll figure that out later. I made it. Do MIT license, why not? All right, so now we just have the single package.json. You can look at it. Yeah, it's got test. Really, this should have been ASP. We'll get to that later. But now if I do, I'm going to use yarn. You can also use npm. It's just what we use here for most of our packages. So if I do yarn install -d or add, sorry, yarn add -d, we'll make it a dev dependency, and I'm going to add near SDK AS. And this should include all of the things that we'll need. And here it goes. So now we have our one dev dependency, and we have this yarn lock file, and then here's our node modules, all our stuff. All right. So now if I make a assembly directory, that's where our AssemblyScript code will live.
You're just following kind of standard naming conventions right now for AssemblyScript, right? So
yeah,
there's like a top-level assembly folder.
Yeah, in fact, the compiler will expect that your AssemblyScript code will live in this folder. The other thing we're going to need is an asconfig.json, which is similar to TypeScript's JSON configuration file, and we provide a asconfig for building. So doing this is all you need to be able to build contracts, because it provides all the necessary stuff. So then the next thing we're going to need is
and so there you're just basically reusing the default, right? You're not overriding anything or adding any features or anything.
Yeah, so here if you wanted to say change what the output was, so right now it's going to expect that your entry file is going to be assembly-index.ts. And then it'll build, and we'll see where it happens when we build it. So here I'm just going to export a simple function and call it hello world, and all this is going to do is return a string. So return hello world. So this is simple enough.
That's a smart contract in AssemblyScript right there with one function.
Yeah. So then now if I do yarn ASB, which stands for AS build, it will then now read in this file. In fact, this is going to be something we're going to want to use anyway, so we can come here and say build and then do ASB. So ASP stands for aspect, and then ASB is AS build. And those are the two that you'll use. So now we have this built thing, and here it is in AssemblyScript. I mean, in WebAssembly. We can't see what that is, but if we really did want to see what it is, we can do yarn ASP-wat, which will rebuild it and then add a text version of it, which we won't get into, but in case you want to see what your actual code looks like, the build, it looks something like this. So
that's just the WebAssembly as text format for this WebAssembly.
Yeah, and by default you can see it's build release, so this is the small version of it. And yeah, so now if we want to add tests, there is an ASP, which comes with a handy -- init, which will create just a sample example.ts here, and see here it's we're getting a complaint that these types don't exist, and this is because we forgot one other thing, which was to create a TS config, because we're using TypeScript IDE. So what this is going to do is similar to how we extended the AssemblyScript /pd assembly.json. And then, and here, luckily, you can hover over and click on it because the compiler knows about it. And so here is the actual thing. So now if we go back to this test file that was complaining earlier, it's now the IDE has found those types and it's happy. So, this F64 type doesn't exist in TypeScript, but now it does for us. So I'm just going to get rid of these tests that come with it, just so that we can import. So now I can say it should return hello world. And so this is just going to be a simple test. And so these describe blocks are just there to bring together semantically similar tests, and you can also have things run before or after each or all the tests.
And this is aspect is what we're looking at, but it basically follows the RSpec convention. So any typical unit testing experience would make all this look really familiar.
Yeah, and so now we're just saying we want this to strict equal this string. And so now if we come here and do yarn ASP, we should get a test and see right now. Oh, we forgot one other thing, which is that this needs to extend our version, which is require near SDK imports. So this is
so this was an auto-generated file when you typed aspect init, and we need to clear that and point in our version of that import, something like that, right?
Yeah. So this sets up all of the things, and in fact it creates this. It hooks up the unit tests to work with this fake VM. So here we have the test, and it passed. And then if we do -- verbose, you can get a little bit more information, just so that it'll show you not just the group level but the test level. And it's a little slower than if we were running just pure AssemblyScript, because we have to connect to this other VM that'll handle the storage if we were actually trying to write to storage. But in this case, we weren't.
We've got some extra machinery that kind of like pretends to be the blockchain, and that's what adds a little bit of overhead there. So just to kind of pause here for a second, starting from a blank folder, you've now basically created a project with one smart contract and one smart contract with one function in the interface of that contract, and one unit test that confirms that function's working. And you also have built that smart contract in the build folder, build release. You have a WASM file that you could deploy now to the near blockchain, testnet, mainnet, whatever, and use it as a smart contract online.
Yeah.
Okay, nice. So that was about 10 minutes. So the plan now for this sort of next chapter, I think, is we're going to take the counter example, maybe just grab the source code from that contract, and then just like bring it in here, write some unit tests, and then refactor it into singleton. It's a slightly different way of representing, of expressing contract functionality in AssemblyScript.
So I'm just going to come here and copy that into here. And just to test that this is building, the yarn build. And while it's doing that, I'm also going to come back here and grab the tests.
And this would work, this process that you're following would work for any of our examples that are written in AssemblyScript. You sort of set up the project, and now you're kind of coming in and grabbing the source code for it.
Yeah. So here I can just blow away what we have here. And this is no longer main. We can just do that. And so here are some handy things from the SDK that we're importing this time. And you'll notice here the two big ones are context and storage. So if we go back and actually now look at it, it did build. Is we have 4 functions, and 3 of them are what we would call change functions, and 1 of them is a view. So from the SDK, we have this storage API, which lets you get and set different values. In this case, it's going to be a primitive value, so an integer that's 32 bits long. That's and we have to give it a key into where in storage to store that value. And here we're going to call it counter. So
because
this is going to
Near's underlying storage, the on-chain storage, is accessible through this key value API, right? It's just like key value pairs, right?
Yeah. And so this is the sort of almost as low level as you can get. It's just a simple wrapper over the API that all WASM contracts will get. And here we're just, whatever value you put in, you will add to it. And here we have this lets you say if it didn't exist in storage, give it a default value of 0. So we also have logging, which lets you say what the new counter is, so that you get this receipt after the fact, and to get verification that the value has changed. And then here we have decrement, and then reset, which just sets it back to 0 and logs that it's been reset. And then this one will read from storage, and if nothing has ever been set, again, it'll just return this default value of 0.
This logging, what you're really doing here is just appending the string, logging log, whatever's logging log, whatever's that string is, you're appending that to some array, some collection that is returned with the transaction outcome. So if you're looking at a website, like Berry Club or Berry Cards or Paris ID, and you see something in the developer console being printed out from the contract, that's because inside the contract there's something like logging log writing that. If you're using near CLI from the command line, that would be reported in the transaction outcome result that you see printed to standard out at the terminal.
Mm-hmm. So there's one more thing that I forgot to add from this project, which is going to be necessary in what we're about to do, which is to bring in this type. So again, this is just to define some global types for the ID that will pick it up. And if you want to click on it.
What reminded you of this?
That we're about to use the bindgen decorator. So as of right now, the bindgen decorator, the type for it is defined globally, and so if you were to try to use it without adding that file, the IDE would be say where did this come from? So
okay, so you were anticipating a problem that we'll see in like a minute or two when we're refactoring this contract, right? But there was no sort of trigger for it. So okay,
I could have waited and shown that, but
no worries. So did the tests pass though? The ones that you pulled in from the repo? Like if you run yarn.
So yarn test members ASP. So now running this, we'll get, again, it's actually going to use the storage. So it's and it's false. So I think so. It's saying that it expected Eve and got Alice. So if we go to the test here, and that was test should have Eve's account. So right now, this context is when you were to make a transaction, you have to set, or in this case, the contract itself has a name. And so this is just checking that the contract's name is Eve. Now, like I said before, I think the other test was using some default config file, but this I think is more explicit if we do it here. So if I do before all, I can do context. Or this is going to be the function that's going to run before all the tests, and I can try. So this requires me to use this import called VM context, which is the way that we can change this mock VM that we're working in, so that we can make it think that it's. So I do set contract name.
Account name probably. Current account ID.
Current account ID. All right.
I think so.
Then this one I can just set as Eve. and then hopefully when we rerun this, it won't work. It will work.
And all you're saying there is that inside this unit test, when the contract is running, the contract believes that its name is Eve. That's what you're doing here, right?
Yeah. And
so can we put that VM context line right next to the test itself?
Yeah, I'm just gonna, since all the tests don't need to have this information, I'll just put it here so that then that way it'll show that hopefully this works. If not, then I can copy that other file, which is another way that you can set these parameters beforehand.
So can you explain why it wasn't working before? Is it because
the defaults are Alice. The contract is named Alice. I don't
the default in the implementation of the underlying like VM that's kind of mocking the blockchain, right? Something like that.
Yeah. And so this is an API to change those defaults. And if we go back to this real quick, you can see here that you can, if you put this context.json file in the folder, then it'll get picked up by it.
Yeah, so this that way you can set a bunch of parameters in like one file, basically.
You don't, and if this is true for all tests, then this becomes the defaults for your tests. And you can see here, there's Eve as the current contract ID.
Nice.
So now if we come back here, we can look at some of the other tests that we're passing. So this one, we're incremented a counter by 1, and these are all those functions that we're importing. So we incremented by 1. We'll go get the counter from storage, and we expect it to be 1. And so you can imagine these other tests kind of go along with it, and each test you can provide a little, or at least each expect you can provide a little context of what, so that when you get the error, it makes sense. But now if we come back here real quick, we can see, okay, well, what's happening here?
Wait a second. These, I think I may have just missed something. So those unit tests that you pulled, those were just unit tests from the counter example, not aspect unit tests?
No, they were aspect.
They were aspect tests, yeah. Because the syntax isn't that similar.
Yeah, in fact, aspect is modeled after the same sort of structure and feel. But what this contract is getting at is that there is this underlying state that is the counter. Here we're being very explicit, which is good to know and understand. But another way we can model this is by using a singleton class, which I will call counter.
And so this you could call this class whatever you want. In some cases, we're kind of defaulting to calling it contract at the top level. Doesn't matter actually what you call it, makes no difference. But the way near-bindgen is working is that maybe you could explain it more clearly. But if you have a class that's exported in the main file that is decorated with near-bindgen, then that class becomes the contract interface, basically, right?
Yeah. So in this top-level file, you'll see in other projects there'll be a model.ts that lives next to it. And this is where then you would, add this bindgen decorator to say that class can be encoded and decoded from storage or to JSON to return. In this case, we're at the top level in this index.ts, and so if we export it from here, the bindgen code will see it and think, okay, this is actually, I'm going to actually convert this from a class that's exported to a set of methods on this class that get exported that then read the state before executing any of the methods. So I can say that there's a private field here called counter, and it's going to be an I of 32, and the default value is going to be 0. And then now if I can say increment counter, but now this is sort of redundant since it's a class on this.
Oh, you're going to change. You're going to change the method names. Can I suggest that we keep the same method names? And in fact, like if you could just select all of the export function phrases and just like copy out the rest of the line to quickly generate the interface. Like, you know what I mean? Like if you just select every instance of export function in this file and just like pull out the interface and copy and paste it, shouldn't that work?
Let's see, and then I do that. But now I don't want to get rid of export functions because they're methods. So if I then come back here and go boom, boom, boom. Yeah, and then okay, oops. All right, which feels a lot, you know, has a simpler feel to it. So now if I do counter minus equals value, and then this one just returns the value.
A counter instead of value.
Oh, counter.
Yeah. And so if you just commented out the methods below this, like it'll build and pass the test, is it that simple, or am I missing something?
No, it's not going to be that simple because before we were importing each function into the tests.
We've got to rewrite the test a little bit now to deal with this new interface, right?
So now if I say import counter, like that, then we can have this global counter here.
Couldn't you just change the syntax of your import statement to extract those functions, like to destructure those functions right from the class?
No, not. It's because from the level of the AssemblyScript sees and TypeScript, it sees just one thing that's being exported, which is the class. If it was a oh, this is counter. If it was a namespace, maybe you could. So here I'm going to say let counter equal counter, and then before each one, I'm going to create a new counter.
Yeah. So what you're doing now is rewriting parts of the unit test without changing the intent of the unit tests. You're rewriting them so that they match this new interface, right? That's the key.
Yeah. Yeah. So then here, each place here, I can go counter dot here. I probably should have copy pasted this. And I'm just gonna use formatter so that I don't have to worry about it as I'm typing. And then now it should.
Yeah, nice. Famous last words. Let's see if it passes.
No, because so one annoying aspect of AssemblyScript is that you still have to declare when things are void. So it just
yeah, you just didn't have a return type on that one function because you typed it out, but the rest of them, when you copied them, you brought the return type with it, right?
Yeah. I can do that and then say maybe format this document too, see if I've got anything. All right.
Nice. So and the tests are passing. Sweet. Yeah. So just to kind of reflect briefly, sorry if I'm cutting you off, but just to reflect briefly, you started with an empty folder, npm init, set it up so that you had a basic hello world contract with one method and one unit test. That structure then you grab the source code from, in this case, the counter contract that we have on near.dev examples. Could have been any contract, really. It makes no difference. If it's written in AssemblyScript, it'll fit into this model. You grab the source code from the contract, you put it in here, and you grab unit tests, the aspect unit test from that example, put it into the structure that you created, everything passed. Then you refactored the contract from this just a list of methods interface to a singleton pattern, and then rejiggered the unit tests so that they fit this new interface. That's literally what we just did in the last 20 minutes or whatever.
Yeah. And in fact, if you were to look at the built singleton that we have here, build dash dash what oh, misspelled build. All right. Okay, hopefully this will finish within the minute we have left. But nice. Here's yeah, so here we should see this file change once this finishes. Boom. All right. So here are the imports that this thing requires from the what do you call it? That's the the host function provided by the runtime, the near runtime. And then here are those methods. So that even though they were methods on this class, they keep the same name. So so actually, if you're using this model, you get the same from the outside, the same API as what we had before.
Yeah, if you did this refactoring for an existing application with a front end or whatever, you wouldn't notice the difference actually. We had to kind of switch up the unit tests because of the way Aspect addresses the method calls, something like that.
Exactly.
Right?
Yeah, and maybe in a later video we can address how, you know, a little bit more, changing the tests to show what's actually happening in more detail.
Nice. This is great. Thank you so much, Willem.